What's happening, guys? In this video, we're going to focus on doing probability with two-way tables. Now, I didn't make a video on how to create a two-way table because more often than not, they are given to you. So I'll talk about how the setup is, and then we'll knock out a few probability questions using it. So, students at a school were classified into whether they are male or female and whether they are in Stuco or not. Those classifications can be represented in a two-way table below. So the gender classification is the rows. So there's our males and female breaking down. So males, there's 15 total. Females, there's 44 total. And then across the top, our columns is, are you in Stuco or are you not in Stuco? So we have 23 students in Stuco, 36 that are not in Stuco. Altogether, we talked to, if you look at our total column and total row, 59 total students, okay? So things that you need to be careful about with these types of questions is they will not always have the total row and the total column. So you might need to add up the rows and add up the columns to get that. So our table comes with our total row, total column, which is great. So let's answer some questions with this, shall we? What is the probability that a randomly selected student is male? So notation, always important. They just want to know what is the probability that we select a student and they are male. So we're not hyper-focusing onto any particular part of this table. You're picking from all possible students, which is all 59 students, and they want to know of all 59 students, how many are classified as male? Well, if you go to the male row, there is 15 total students out of the 59 that are male. So you could represent that as the fraction. I already went ahead and did the division there. You get 0.2542. So you have a 25.42% chance at randomly selecting a male from this group. B, what is the probability that a randomly selected student is in Stuco or is a female? So there is that keyword or there that we're going to have to keep our eye on. But let's write out the notation first, and then we'll deal with the table. So a randomly selected student is in Stuco or is a female. So student or female. The reason why I highlighted that or is, remember, or means add things together. So I'm going to go a little bit more visual with this one, to kind of show you what's going on. If you've seen my earlier videos, I try and avoid the formula route. You can still do that if you want, but I'm all about visualizing probability questions so you know what to do. So they want to know what's the probability that is Stuco or female. So let's first start with the Stuco. Well, Stuco is this column right here, those students right there. So what's the probability of just selecting a Stuco student? Well, there's 23 students in Stuco out of a possible 59. So we're talking 23 out of 59. So count up all these guys, it's 23 out of a possible 59. Our or here means add things together. Our other thing that we're looking at is Stuco or female, okay, or female. So if we go to the female row, we're talking these numbers right here, okay. So Stuco or female, well, there's 44 females out of a possible 59. Now, the reason why I like to highlight the row and the column that we're focusing on there is we should see that things were not disjoint. They were not mutually exclusive, meaning there was overlap there. My yellow rectangle and my gray rectangle, we overlapped right here. So these 18 students were counted when we did Stuco, and we counted them again when we did female. So I counted those 18 students twice. So what we need to do is we need to subtract off this overlapping spot, which is females that are also in Stuco. So we need to subtract off those 18 because I counted them twice. So what we could do is do 23 over 59 plus 44 over 59 minus 18 over 59, okay? When I do that, and I'm quickly doing this answer for us, 49 over 59, if there was no overlap, then there's no need to subtract there, okay? If there's no overlap, there's no need to subtract because they are disjoint, they're mutually exclusive. You could just add them together and be done with it. But because there was overlap, we subtracted off the overlap. And if you're one of the folks that you love formulas and love going that route, essentially what I did here is I did kind of follow along with the formula, but with having no reference to it, okay? This is the probability of Stuco, this is the probability of female, and I subtracted off the probability of Stuco and female. I went the formula route where you're logically working through these problems. It's nothing too crazy. By the way, if you take 49 over 59, that is 0.8305. So the probability that you randomly select a student that is in Stuco or is female, you have an 83% chance of doing that. 2 more questions here and we are done. What is the probability that a randomly selected student is female and is not in Stuco? So let's set up that notation first. I do see an and there. Said female and not in Stuco. Now, a lot of people see this and they think, hey, I gotta multiply. Really just pay attention to what you're trying to find, okay? Don't get too caught up into, I need to do this and this is how it's done. Just pay attention to what you're doing. So we need to find the females that are not in Stuco. So female and not in Stuco. If we look at my table up above, whole bunch of numbers there, let's find the area that represents females and not in Stuco. Well, here's my female row and my not in Stuco column, which runs together at this 26 students. These 26 students are considered female and not in Stuco. So you notice I don't need to do any sort of multiplying there. We're just talking about those 26 students out of a possible 59. There's nothing that needs to happen there. Just find what you're trying to look for in the table. By the way, if you divide those, I want to go the decimal route or percentage route. That is 44.07%. Final question here. Given that a student is female, what is the probability that they're in Stuco? So I am seeing one of our keywords jump off the page there. Given is jumping off the page. So set up the notation first, and then we'll go and try and figure this probability out. Given that the student is female, so in the back we're going to put female. The knowledge that we currently have is this student that we have selected, we know for a fact is a female. So given that it is a female, what is the probability that they're in Stuco? So Stuco given female. So let's kind of visualize this up above. So the knowledge we are given is they are a female. So I am stuck to this row. Okay, we are stuck to this row, which I'm trying my best to highlight with my red pen here. They gave us the knowledge. It is a female. So we don't care about the numbers on the outside of what I just highlighted. This 59 is no longer important. This 36, 23, 5, 10, 50, they're no longer important. We are stuck to the female row. So how big is that female pie? Because I like to talk about conditional probabilities given problems as a piece of the pie divided by the entire pie. So the size of this group is 44 students. So you'll notice, compared to the previous 3 problems I did, all these other ones were out of 59, out of 59, out of 59. For a given situation, we're now out of 44 here because we are in the female row. Now, given that we are a female in the female row, we need to figure out, all right, of this 44 total, how many are classified as in Stuco? Well, only focusing on this row, well, there's 18 students there that are female and in Stuco. So we're doing 18 over 44, okay? So you see how we kind of focused in just on that female row and dealt with just the probabilities inside of there. So of my pi, which is a size of 44 females, 18 of them are in Stuco. If you take 18 over 44, we're talking 0.4091. Okay, that was a quick rundown of how to do probabilities with two-way tables.